Welcome back. In this video, we're going to work on a few things. We're going to add a buffer to the silences. So if I click on detect silences, we can see that the words are no longer being cut off immediately after they're spoken. And then there's also some silence before the next word is said. And this is to prevent clipping. So clipping is when you're speaking and then suddenly it gets cut off from the audio, and it makes this clipping sound because you cut off the audio before it reached zero volume. And then we're also going to add these little X icons so that I can remove the detected silences in case I don't want to include these deletions in my final edit of the video. And then we're also going to enable zoom, so we're going to add these buttons here. So if I were to click zoom in, it zooms in, and then I can scroll on my timeline in case I want to get a closer view of the silent regions. All right, let's get started. All right, so as usual, we're going to go into cursor here, and we're just going to start up the application. And I just remembered that I never explained the code from the last commit in the previous video, which is the implementation of WhisperX timestamp parameters. So let's go ahead and do that now. That was our last commit, so let me just run git checkout and then that commit ID with the little top hat and then soft. Actually, let me correct that. Git reset. That'll bring us to right before we made this commit. Okay, so here are all my changes, and let me just go through them. If you remember from the previous video, we have this WhisperX command that we submitted into the command line. And this is the command that ultimately got us the accurate transcription. And so I'm going to prompt cursor with this prompt, or rather I did. Here's the prompt that I have over here. So I'll just read it out. Below is the shell command to get WhisperX to return accurate word level timestamps in its transcription. Please implement these parameters into my Python implementation of the library. I have also provided the WhisperX documentation for reference. You can see if I go into the prompt where I submitted that, I have the WhisperX command in this notepad file. So it was just this right here. And then I have the WhisperX documentation saved in another notepad. You won't be able to see it because I think I'm in the way, but I have my notepads here on the bottom left. And so those are the two files that I provided as the context. And then I provided the backend transcribe file, which is the file that contains my API endpoints. All right, continuing with the prompt. Please adjust my transcribe service so that it passes these parameters into the backend when it makes the request. Please make sure that my generate transcription from video editor context and any other function that is using the transcribe service is passing these into the transcribe service. So basically I'm just telling it, this is a working version of the command that we need to give WhisperX along with the parameters that we need to provide WhisperX with. Please update my project so that it's using these parameters so that whenever we're transcribing an audio file with the React project that we've built, it's using these parameters in the backend. And so when I submit that, it makes a few changes. It makes changes to the transcribe service, and I'll go over them right now. And then it provides a summary of all of the changes that it did. So let me open up that transcribe file. All right, I have it open here on the left. And then I had to actually prompt it a little bit more because in my original prompt, I didn't have all these details. So I just had to keep prompting it a few more times to make sure that it did everything that I wanted it to do. For example, I needed to provide it with the transcript-based file. And then I also reminded it that it needs to make this update in that file too, because that's the front end file that's passing in the parameters to the backend. So that's all I'm telling it here with, can you please adjust my transcribe service so that it passes these parameters into the backend when it makes the request. And so then it goes into the transcribe service and makes those changes. And then I think, yeah, I had to prompt it one more time, and I had to remind it to make an update in the video editor context. And I just tell it, can you please make sure that my generate transcription from video editor context and any other function that is using the transcribe service is passing these into the transcribe service? Because basically these options here, these parameters, weren't being passed in from the front end. And so I just had to make sure that they're being passed along in all of the files that are ultimately leading to making that request to the transcribe service. And then once I've made all those changes, then I made the commit to save all of those changes. But let's look into the files that were changed in this thread. So starting off with the transcribe service, let's take a look at the changes that were made in this file. And we can see that this getAlignModel function now accepts the align model as the input. And what is calling this function? Let me just take a look. Okay, it's being called down here and the align model is being passed in. That is passed in by the transcribe endpoint handler, which is called transcribe audio. So we're passing in the align model, and the align model, where's it coming from? It's coming in to the endpoint handler from the request itself. It is an optional parameter that's passed into the request, and if none is passed, then it just defaults to none. And this is why I had to keep prompting cursor to update the front end files, because it made all these changes here to the back end, but I never made the changes to the front end in order to actually get this align model passed in from the front end. So let's take a look at the other files that I changed. I think it's the transcribe service where it starts. So I'm looking for where it makes that request. So this isn't it. This is just the transcribe service. This is, well, actually this is where it's making the request. We have these two functions, transcribe blob for when we're working with a blob URL. And then we have this function down here, transcribe file, for when we're working with a file. And both of these are assigning these parameters. So the model name, the batch size, the language, align model, highlight words, whether it's true or false, and then BAD onset. It's getting them from the form, rather it's attaching them to the form, and it's getting them from this options right here. So before it makes the request down here to the backend, it's appending these parameters into the form data that's ultimately going to be passed into the request body. And then similarly down here for the transcribe file, this is just working with a different format of the audio file. It's just making sure that it's appending these parameters into the payload that's going to be sent to the backend request. So we can see that this is where it's providing these into the form data that is used to make the backend request, but this isn't where they're coming from, right? Because this is just the service that's used, and these options are defined when these functions are called. So let's go into where these functions are being called, and that would be in the video editor context. Okay, so I have it open here. You can see these are the options that we have in our original WhisperX command down here, and these are being created up here in this file. Eventually we'll create them somewhere else, and we can even let the user select these parameters if we want, but they're just static values right now in our app. And these options are being passed into this generate transcription right here, and it's from this input that the generate transcription extracts the options, the parameters, and passes them into the transcribe services, whichever one we're using that we just looked at, either the transcribe blob or the transcribe file. And then what else do we have? Here it's just exporting this transcription options variable, which is this one down here, I guess, so that other functions can use it. So those were all the file changes. We still have to review the transcribe backend file, but we can see that this generate transcription is now expecting the parameters to be passed in as the input. So where is this function being called? Let me just search the entire code base. Let me expand. Okay, I found it. It's right here in the transcription panel. This is what's calling the generate transcription function from the video editor context, but we commented it out because we're not using it right now. If you remember, in these last few videos, we haven't been starting up the backend because we haven't been generating the transcription every time we go into the application. So that's why we have this commented out. So we just got to make sure that once we do uncomment this and we're generating transcriptions for any files that we're working with, that we're passing in the options so that WhisperX is working as we expect. And that's why in the video editor context, let me open up that file again. That's why it's being, if we look at the top here, these transcription options that are defined statically in this file, they're being exported by the video editor context down here, so that whenever I want to call the generate transcription, I can pass in those parameters by importing them from the video editor context. So I would just add it right here, and I would say transcript options, and then I would provide these options into my generate transcription file down here. And this is what it looks like when it's not commented. But right now we're not going to be using it still, so I'll just leave that commented. Okay, so we've already taken a look at all the front end file changes. So let me just stage those, video editor context. And then there were a few other files that were changed. I'm going to end with the transcribe backend service. But if we look at the, let me zoom out so we can see it better. This is the transcription on the right that was generated using these new parameters. So you can see it just changed the timestamps for these words. And then there were probably words as well. Let's see, there were numbers, right? It was the numbers that I had trouble with. So if I scroll down right here, 2016, on the left was our manual edits that we had written in order to get the transcription to work correctly, but we don't want to have to manually edit our transcription. And on the right here is the timestamps that are generated using the WhisperX. And so it was able to detect the timestamps for numbers, which before I had trouble with. So let me just stage that file as well. And then another change that was made was the WhisperX library. It was just updated to the latest one at the time of this recording, which is version 3.3.3. So I'll just stage that as well. And then there's this example file that shows us how to, let me zoom in, shows us how to use the WhisperX model. And this is ultimately the same thing that we have in our backend. It has some other utility files like to display the results if we want to see the transcription. And then here's this main file in order to run the WhisperX model from Python. But we're not going to use this project. We're not going to use this file in our project. This was just something that Cursor generated so that we can see that it's working with new parameters that we had defined. But I'll make sure to include it. All right, so finally, let's look into the transcribe service, the backend handler of the request to transcribe the audio. So as we saw, this is as far as we got last time. We pass in the align model into this get align model here. It's just creating this model key to look for that model in what we have defined as our available align models, this global variable. And where's that defined? Let me just look for it. Up here, so we haven't defined any. Okay, so there's no reason why I would find it based on that. So this is probably never going to run unless we define some align models up there. And here is where we're loading the WhisperX align model. Since we didn't find it up here, we're going to provide it down here as the model name into the WhisperX load align model method. And then once we get that model and the metadata for it, then we're just returning it right here. So let me scroll down to the rest. In this transcription request, you can see that we've added more parameters to provide in the transcription request, and these are optional. So the align model that we're using is just from the WhisperX command. You can see that it's this one here. So now we can supply that in the transcription request. We have this boolean here, highlight words, that defaults to false, and then the VAD onset which is an optional float value. Let's keep going. Here's the transcribe endpoint handler, and as we saw from the front end, we're passing these in the request. We keep scrolling, we can see how they're being used down here. So before we were just transcribing the audio using the batch size and the language, but this time we have more parameters, right? So now we're checking that the VAD onset is present. If it is, then we add it to the VAD parameters dictionary here, and then we call the transcribe service using those VAD parameters. And then once we get the transcription, before we were just getting the align model using the language code, but now we're also passing in a specific model that we want to use for the align model. So once we get that model from the getAlign model function that we looked at just a few seconds ago, then we can call this whisperx align so that it aligns the timestamps with the end of the words and no words are getting cut off. All right, let's keep going. Okay, so we changed the format of our response. We can see before we had this, the response was text, segment, and language. And actually we still have text, segment, and language, but we're also adding into the response whether the words were highlighted, and then we're returning the response. So that's all we're doing. We're just adding in this extra dictionary value into our response from the backend. And then for this transcribe file endpoint, it's going to be the same thing. These two functions that handle, so this one handles the file endpoint, the other one is for just the audio itself. They're doing the same thing. One just handles the file. So we can see that the changes that we made in here are the same that we had made in the previous function. Really, we only need one of these in our production. Right now, the reason we have both is because for our testing purposes, we have the file saved into our server. Okay, so those were all the changes. I just wanted to make sure I covered them because I didn't cover these in the last video, and I want to make sure that you're able to follow along with the changes that we're making to the app so that you can understand this entire code base. All right, so let's move on to the other changes that we've made. Okay, so the next thing that we're going to look at is how we added the padding into the silences. So you can see right here, it doesn't cut off the word as soon as it's done being spoken. And the reason we're doing that is because we don't want to cut off the words while they're still being spoken. And this prevents clipping. So let me show you the changes that we made. All right, so I have here the thread where I prompted those changes. And I just started off with asking it which of these files contains the transcription timestamps, which handles the detect silences feature, because it had been a while since I've worked on it. So I just provided it the entire file structure of all of my components, and I just asked for O to tell me that so I can quickly remember which are the files that I need to work with in order to make the change. And then in order to prompt cursor to do this correctly, here's the prompt that I gave it. The video editor context has a callback function called detect silences that sets the silences according to the provided transcription. So if I go into the video editor context, let me just close these files. Video editor context. All right, so this is the detect silences function in the video editor context. And this detect silences function uses these silences in order to update the trim history. The problem is that the timestamps of the transcription are very precise, and so the silent regions that it creates around the word gaps are too close to the end and start of speech. We need to add a buffer to the silences to prevent any words from potentially being cut off in the audio. Whenever a silent region is created using the transcription timestamps, there should be a buffer of 0.2 seconds at both the start and end of the silence gap. Meaning, if there's a detected silence that is 1 second long, then the silent region start time needs to be delayed by 0.2 seconds and the end 0.2 seconds early. Therefore, the silent region will be less than 1.0 seconds because of the padding that we added before the start of the silence and after the end of the silence. If the resulting silence gap falls under 0.5 seconds, then filter it out. The reason we want that is because if you're cutting out 0.3 seconds, for example, then it's just an unnecessary edit, and we don't want to cut out 0.3 seconds because it's not even noticeable to the user. So we just want to make sure that as long as the silence gap that results after we added the padding is equal to or longer than 0.5 seconds, then it stays. Otherwise, it just gets removed from the list of trim history edits to make. And then lastly, only the remaining silent regions that exceed 0.5 seconds should remain. Can you please create the logic to adjust the silences that are returned by detect silences core to add this padding? And this detect silences core is a function. This is where we're figuring out what the silence gaps are. You can see we have the detect silences core here, and this is where it's calculating the time gaps. All right, going back into the prompt. You're welcome to add this function in the same file that contains the detect silences core function, which is this utility file here called silence detection. And so with that prompt, it made all of these changes. So we can see in this video editor context, we're now importing this new function called adjust silences with padding. It's being imported from that utility file. And let's see how it's being used in the video editor context. All right, so we've updated this detect silences callback function in the video editor context to include a padding of 0.2 seconds. And then it uses that padding along with the raw silences that we had gotten from this detect silences core function. And we adjust the silences. So we'll take a look at what this function is doing, but we can see that all it's doing is basically filtering out any of the raw silences that are no longer at least 0.5 seconds. And it's also adjusting the times with this padding. So now it's just checking that we still have some silent regions remaining after we added this padding and filter out the short silences, and then setting the trim history according to those adjusted silences, just like we were before, but now we're no longer working with raw silences, we're working with adjusted silences. So that's all that's changed in the video editor context. And if we look into where this detect silences is being called, it's ultimately being called when I press this detect silences button, which is in the playback controls. So we don't need to look at the code for that. But let's take a look at what this adjust silences with padding function is doing. And that's going to be in that utility file, silence detection here. So we can see that for the detect silences core, I just made a small modification because it was creating the IDs of the silent regions. It was creating them according to the start and end time of that silence gap. But since we're adjusting these start and end times later, then it doesn't make sense to continue using that. So I just use a midpoint. So now any silent region is ID'd by the midpoint of that silent region. And then same thing down here. But let's see, this is the function right here, adjust silences with padding. So it takes in the silences that were returned by this detect silences core function, and then it takes in a padding value, which we have it set to 0.2 seconds, and then this is the minimum silence duration to make sure that our silences are at least 500 milliseconds long. And then using these silences, it maps each of them to new start times and new end times. By adjusting them with this padding, it calculates the new gap based on these new start and end times, and then it creates this adjusted silence using the new start and end times, and it returns that adjusted silence to this mapping function. So these are the new adjusted silences. So it really is just that simple. It's just calculating these new start and end times, calculating the gap, and as long as that gap exceeds that minimum silence duration, which is 0.5 seconds, then it is added to the adjusted silences. Otherwise, it returns null, and then that gets filtered out right here. Any null values in this adjusted silences list or array are just filtered out. So pretty simple. That's what enables us to be able to add this padding and just a few code changes. Now we can see that there's no risk of cutting off words before they're done being spoken or before they start being spoken. As usual, I'll make sure to put in the comments and the description of this video this prompt that I use in order to generate this code in case you want to give it a try yourself. All right, let's move on to the next change we made, and that's going to be adding zoom buttons. So zoom in and zoom out, because right now I'm seeing the whole audio waveform, right? But I'd like to be able to zoom in to a specific region, and I can't do it with my mouse because it just zooms in the whole page. I can't try to scroll because it doesn't move the audio waveform. So we're gonna enable zooming in to the audio waveform so that if we have a really long audio, we can zoom in to maybe like a 1 minute view instead of, for a 60-minute video, we are not just looking at like the entire 60 minutes of the audio. So you'll notice that I'm doing things a little bit differently. In the previous videos, I was coding along as I was making these changes, but it was taking quite a bit of time to do it that way, and I wasn't able to develop as quickly as I wanted. So I figured that it's better if I just make all the changes that I want and then present them to you guys after I've implemented those changes. Okay, so now let's take a look at how we implement this zoom in and zoom out. So if I click on here and I want to zoom into a specific part of the video right here, for example, then I can just select it on the audio waveform and then I can click the zoom in button, and you can see that the audio waveform is zooming in on that audio region, and then I can move around as well. The reason we would want that is so that if we wanted to edit a specific silence, for example, I wanted to zoom into this region right here, I can zoom in and then I can adjust these if I want. So when this region gets cut out, I have a little bit more control over the regions that are edited. So I'll jump back into the code. And I was able to one-shot prompt this implementation with the following prompt. I would like to be able to zoom in to my audio waveform. Right now, when the audio waveform is displayed, it shows the entire audio duration. This is a problem for very long videos where the audio waveform will have to be very zoomed out in order to display the whole thing. I would like to be able to move around inside of the audio waveform with my mouse movements. Basically allow me to scroll the audio waveform to the left and to the right, and allow me to zoom in and out of the audio waveform so that I can visualize it better. Can you please implement this logic so that my audio waveform is more interactive? If you need to add buttons to the zoom in and to zoom out of the audio waveform, please add them to the playback controls. Please refer to the wavesurfer.js documentation to figure out how to do this correctly. And this was the most important prompt right here, because maybe the LLM had been trained on the wavesurfer.js library, but it could be that the last time it was trained was before a lot of recent changes to the library, and so it may not have been trained on the most recent information of that library. And so I provided it with the wavesurfer documents, and when I provided it, I saw that it was recently indexed, so that tells me that it does have the latest documentation. Then I also gave it access to the web in case it needed to do any kind of research. And then I provided it with the files that it's going to need. So the audio waveform, obviously, because that's what contains our audio waveform. And then the video editor context, because that's where we manage our state for the edit page. And then the playback controls, because that's where it's going to need to add the zoom in and zoom out buttons right here. So with that prompt, we can see that it thought for 7 seconds. And we can see that in its thought process, it says based on the documentation, and then it provides the link. So it does use the documentation of Wavesurfer in order to figure out what it needs to do. And let's see what it implemented. So first it says it's going to use the minimap plugin of wavesurfer.js. And what this does, it displays a smaller version of the waveform that acts as a scroll bar so that you can navigate the main waveform. But I actually didn't see that anywhere, so maybe it's hidden. But let's look at where it implemented that. So here we are in the audio waveform file, and we can see that it's importing the minimap plugin. And then in this effect hook, which is the effect hook that is initializing the wavesurfer, we can see that it's instantiating this minimap plugin, and then it's passing it in as a plugin to the wavesurfer object. So that's all that was changed inside of this audio waveform. And then what else did it do? So for the zooming, it says that wavesurfer.js provides a zoom method on the main instance. We'll create a new function in your video editor context to handle calls to this method. So let's take a look at that video editor context. And we have this callback function here with no dependencies. It's just whenever it's being called, it's zooming in on the wavesurfer object according to the level that's provided as the input. And then if we scroll to the bottom, the only other change is that it's exporting this handle zoom. So I'm guessing this handle zoom is what's being called by the playback controls whenever I click on the zoom in or zoom out button. And then lastly, the change that I made is to the playback controls. We'll add zoom in and zoom out buttons to the playback controls component. These buttons will trigger the zoom function, which is this handle zoom callback function here. So let's take a look at the playback controls, and we can see that it's importing the handle zoom callback function and then the wavesurfer reference. And then down here, it has the logic for these buttons. So we have the zoom in button right here. And then whenever it's clicked, it's calling this handle zoom with the following values. It's basically just adding 20 units to the current value of the minimum pixels per second of the wavesurfer object. And that's it. Just a few changes that enable us to zoom in and out. And it's thanks to the features that are already implemented with wavesurfer. And if wavesurfer didn't already have these features implemented, it would take a lot more work in order to enable that. But that's why that part of the prompt where I tell it to refer to the wavesurfer documentation is the most important part, because if I hadn't told it that, it probably would have tried to implement all of this logic without knowing that this can already be done with wavesurfer. The reason I already knew that is because I actually asked Perplexity, does wavesurfer.js allow scrolling and zooming in and out of its objects? And so I did a little bit of research to figure out how to do that. And then using this research, I knew how to prompt cursor so that it could implement this correctly. And the last thing that we did is add these icons right here, these little X icons, so that we can undo certain trim regions. So in case I don't want to delete this part of my video, then I could just click on that X and then it removes it, so that when in future videos, when I want to export this video with all of these cutouts, then I can have control over what actual cutouts I want to leave in and which ones I want to remove. And then if we ever have a region that's really small, for example, it might be in the way, but I'll move around so that you can see it better. Over here, let me just zoom in. This region right here, when we're zoomed out, it's kind of hard to see it. Let me just zoom in and then I'll scroll it in view. Now you can see that it's a little easier to see. So I can adjust it if I want to, or if I wasn't able to click delete before because it was just too small, then now I can do it with zooming in and out. All right, so let's take a look at the logic that enables us to remove these. Here's the prompt that I gave cursor. And I forgot to say that I've been using Gemini 2.5 Pro because it's just amazing. It works so fast and it understands really well what I'm trying to do. And so I've been using that over Claude 3.5 or Claude 3.7. Although some people say that they prefer 3.5 over 3.7. I prefer Gemini 2.5 Pro over both of those, at least right now. But it's always changing. In fact, by the time you see this video, we might have Claude version 7.5 or whatever. So here's the prompt. I would like to create a small icon on the regions of the audio waveform that when I click on it, it deletes that region from the trim history. And since the audio waveform is just displaying the regions that are in the trim history, that's the state value, it will also remove it from the audio waveform. Please use the wavesurfer.js documentation in order to implement this feature. And then it made the changes, and then I just had to prompt it one more time to center. Please center this icon on the region. Right now it's showing up on the top left. So I just included that in my prompt. The prompts that you'll see in the description will have that detail as well. But you can see that all I gave it was the wavesurfer the documentation. And you can see that it thought for 16 seconds and it used all of these files in order to figure out what to do. It says that it understands what I want it to do. It just adds a delete icon to each audio region. When the icon is clicked, the corresponding region should be removed from both the visual waveform and the underlying trim history data structure. And so the plan that it put together is, first it needs to understand how these regions are being created, and it understands that it's using the regions plugin to create these visual overlays. And these regions usually have start, end, and ID properties. And for these regions, it's going to need to access the DOM element for these regions. It's going to create an HTML element that's going to be the delete icon. It's going to be appended to the region's main element and then position the icon correctly in the region. And then for the handling of the icon clicks, it's going to have an event listener where when you click on it, at least when you click on the delete icon, it will identify the specific region that that icon belongs to by the region's ID. And then using the wavesurfer documentation, it knows that the wavesurfer API has a method called remove right here, where you can apply that method on a region based on the region ID in order to remove that region from the audio waveform. And when that region is removed, then it's going to update the trim history data structure to remove that trim region from that data structure. And then lastly, it's going to apply some styling to that icon. So it sounds like a good plan, but I didn't give it any of my files to work with. So it's going to look into my entire code structure to figure out how I'm using the wavesurfer library. So it's just searching my entire code base for the regions plugin. It identifies the files that it needs to work with. The video editor context is used to manage the state. The audio waveform component initializes the wavesurfer object with the regions plugin. And it recognizes that it doesn't need to implement logic to manually manage adding regions from the scratch when the trim history changes, because that logic has already been implemented in my code base. So the main changes that it's going to need to make is to just modify the trim history, because the delete action will remove that item from the trim history array in the video editor context, and then it's the audio waveform component that re-renders regions based on the trim history. So whenever I remove an item from the trim history, it updates that state and it will automatically remove it from the waveform. So it says that it doesn't actually need to call the remove method because the audio waveform automatically does that. So let's see its refined plan. So it's going to modify the video editor context. Let's open up that file and let's see what changes it made. So it adds this remove trim from history callback function. It has no dependencies. All it's receiving is the ID to remove. And it's going to create this updated history. Using the previous trim history, it's just going to filter out the item according to the ID that we're trying to remove. So once it finds that ID of the one that we're trying to remove and this returns false, then it's going to filter it out, and then we're going to get a new list. And wherever this is being called, let's look it up. So it's being called inside of the audio waveform. We can see that it's imported here, and then it's being called down here. So we have this region created listener, and whenever we create a region, we're going to create a delete icon for that region. As it said in the plan, it's using HTML. It's appending that icon to the children of that region element, that region DOM element, and then it's going to add an event listener to that delete icon so that when I click on it, it's going to call the remove trim from history on that specific ID. Okay, easy enough. What other file changes were made? Okay, so that's it. It's just those two. So we didn't even need to use the wavesurfer.remove method because of the way our application is already re-rendering based on the trim history. So it's just those two small changes. And then here we have in the component CSS, these are just styling changes that it made in order to get it to work. So we can look at the rest of the plan that it has, but I mean, looking at the code was easy enough to understand what it did, but you can look at the summary here of the changes that it made to the video editor context, and then it makes those changes that it said it was going to the audio waveform. And then lastly, once it makes those changes, it summarizes all the changes that it made. But the code was actually easier to read than all of this text. And sometimes that's the case. So it's important that you understand the code too, because you can develop a lot faster if you already know how to read the code. So with that, we can commit these changes. And so I just gave it this commit one command like I have before, where it looks at the stage changes and then it summarizes them into a commit message. And that's it. In this video, we made a lot of changes. We added the icon here for removing any trim regions we don't want to cut out from our final video, we enabled zoom so that we can have a better view of our video, the audio waveform. And then we added padding by default into our silent regions so that it's not so close to the start or the end of the words, and we're not accidentally clipping the words by cutting too closely. So with that, I'll wrap up this video. Thanks for sticking along. I know it's a little bit different than how I've been doing it in the past, where I was coding along, but hopefully you still learn a lot from this approach, because I'll be able to develop a lot faster, and so I'll be able to show a lot more changes that I was able to make in between each video. If you found this video valuable, please give it a like. It really helps out the algorithm show this video to more people. And if you want to see more like it, make sure to subscribe.